DevOps offers a transformational shift in software development and delivery, driving collaboration and efficiency to deliver better quality software faster. Manual processes, poor visibility, and the inability to measure effectiveness and drive continuous improvement lead to increased cost, lower quality software, and frustration. By embracing a few fundamental practices, teams can improve efficiency, collaboration, and quality. Salesforce development and functional teams have been slower to adopt DevOps than the rest of the organization. This is primarily driven by the complexity of the environment and a lack of supporting tools. A successful DevOps solution for any application or technology anchors on effective adoption of a source control management system such as Git. Source control management systems not only provide revision history of every single change, but also enable productivity through continuous integration. In this video, we will explore how FlexDeploy accelerates Git adoption through integrated tooling and how it serves as the backbone to successful and effective software development and delivery. Let's take a look at the Trailblazer mobile application. This project is associated with an empty GitHub repository. While we are using GitHub for this demo, the same features apply to GitLab, Bitbucket, and Azure DevOps Git. The project is also connected to a Salesforce sandbox org, where we will perform the development. Integrated into the FlexDeploy project is the ability to compare the org to our GitHub repository. Since the repository is initially empty, all objects in the org will be displayed. Here we can simply review the changes and commit them to GitHub. No need to pre-populate the repository, and no need for another Git client. During the compare, we can see which files are new, modified, or deleted. We can also drill in to see the exact changes which were made within the sandbox org. In this comparison, we can see that the only changes are to a single Apex class. After reviewing the change, we can select the file and commit it to the repository along with a comment. FlexDeploy also supports org-to-org comparison, allowing migration without the use of a source control system. We will not cover that topic in this demo, as the best practice is to use a source control repository, so that we have complete revision history of each change and can incorporate valuable DevOps concepts like continuous integration. Now that we have synced the sandbox org to the Git repository, let's take a look at the file catalog. The file catalog is an automatic discovery of the Salesforce objects from the Git repository. The files are discovered and metadata is collected. This catalog is the inventory of objects, which can now be added to FlexDeploy packages. Think of a package as simply a container of objects from the catalog, an entity which will be built and deployed across the pipeline. Here I have created a package called Allied7. In this example, the package coincides with the Jira issues mapping to an enhancement. We can now add objects from the file catalog which we have modified as part of the feature development. I have added a few objects from the file catalog already. We can also find dependencies and add them to the package automatically. For profiles, we can also add specific subcomponents that we need to migrate, rather than the entire profile, which may conflict with the development activities of other team members. Triggering a manual build for the package will pull the latest revision of those files from the GitHub repository. However, in this case, we want to initiate the build automatically as soon as changes are synced from the sandbox org to the GitHub repository. Using a webhook integration from GitHub to FlexDeploy, as soon as we commit a change, a build was triggered for the package containing that object. Now as I drill into the build execution, we can see a summary, which includes lineage to the Jira issue and the Git commit ID. The change logs show the Git commits that are part of this build, along with the committer details. The Steps tab shows the details of the workflow which performed the build. The build workflow for this example fetches the latest revision of the package files from GitHub, performs a static code analysis using PMD, and assembles, versions, and stores the artifact in FlexDeploy's inbuilt artifact repository. To gain further insight into the workflow steps or to debug a failure, we can drill into the logs which are captured for each step. The results of the PMD scan are accessible on the Scan Results tab. Here we can see that there are no critical or high issues, but we have several medium issues to investigate. You will see in subsequent videos that we can utilize the scan results to make decisions within the pipelines. In this video, we've learned how FlexDeploy's native support for Salesforce removes the complexities and barriers to adopting source control best practices that otherwise impede or intimidate many Salesforce users. We saw how easy it is to identify differences between a Salesforce org and a linked source code repository and commit any changes. We discovered how new files in Git are automatically populated into FlexDeploy's file catalog. We learned how files from the catalog can be used to create packages representing the changes for a feature or bug fix. We discovered how continuous integration can be utilized to perform automated builds whenever changes are detected in the source code repository. And finally, we explored the details of the build execution, which takes advantage of the Salesforce plugin to perform the build and a PMD code scan. In the next video, we will see how the new build can be deployed to one or more environments, on demand or orchestrated through a pipeline.